In this video, I would like to go over geometric sequences and series, which are topics in 9.3 of our textbook. In this section, we have three formulas that we use. The first one is for finding any one term in the sequence. The second one is a partial sum that is finite. Finite number of items that we add. The third one is for finding a partial sum. Actually, for finding an infinite sum. Okay, well, let me give you some examples of what geometric sequences look like. Up here at the top, I have the sequence that doubles every single time to get the next number. So 1, 2, 4, 8, 16, and it doubles every single time. So we say that there's a common ratio, and the common ratio here is 2. And this common ratio gives me the number that you multiply each one to get the next one. So that's what makes this geometric. Alright, if we take a look at B, B is also geometric because there is a number that we multiply each one to get the next one. And that number is the same throughout the sequence. Okay, and the answer is R is equal to 1/2. The common ratio is 1/2. So what that is saying is you take half of the number to get the next one. And that is the pattern throughout. Okay, now if we have these geometric sequences or series, then we can apply these formulas. Let's take a look at the first problem here. I'm asking you to find the partial sum that is finite from 1 to 8 of this expression. Okay, well, we start with the 1 plug it into the k. We get 3 to the 1 is 3 times 1/2 is 3/2, and then we plug in 2. 3 squared is 9. 9 times 1/2 is 9/2, and we go all the way to 8, and then I can collect all of them and add it up, and that's going to be my answer. Another way to find the sum is to use the formula. Now it's finite, so I will be using this middle formula, finite. Okay. Now if I'm going to use it, I need to know what A1 is, and in this case I can see that it's 3/2. I need to know what R is, and in this case there is a common ratio, and the common ratio is that you multiply each one by 3 to get the next one. And actually, if I take a look at the parentheses here, that tells me what R is. R is the number inside the parentheses, 3, and we can see it right here. R is the base. Okay, so that's a quick way of figuring out what R is. R is 3 in this particular case. And then how many items am I going to add altogether? Well, there's 8. Starting with 1, there's 8. Okay, so I'm going to go ahead and plug it in. Okay, so starting with A1 here, parentheses. Okay, so we can do this with our calculator, and let me take a moment and compute that. And I get the answer is 4,920, which is a pretty large number. Okay, now let me do a second example here. In this next example, I will be computing the sum, the infinite sum of this expression here when we plug in the numbers 1 all the way to infinity. Okay, now I know that sounds a little crazy to be adding something that is infinite, that is never ending. However, it is possible under certain conditions here. Okay, and the condition is that if you expand this out, the series, that it looks similar to the example B up here, and not like the first one. But example B, if you take a look at B, the difference between B and A is that B gets smaller as we go forward. And in that kind of situation, you can find the sum even though you keep adding an infinite number of terms. Okay. Another way to know when it is possible to add it is when the common ratio, and in this case the common ratio is equal to 1/2, because it's right here inside the parentheses, and you can see here that r is the base again. Okay, so when the common ratio is within 1 unit away from 0, then it is possible to do the calculation. Okay, so in this particular case, we need r is 1/2, a1. A1 is the number in front of the base, and in this case it's a, 8. So that's a1, and this is r. Okay, so we'll need that 8, and we don't need the n in this particular problem, in this particular calculation. Okay, so I'm going to go ahead and figure it out then. All right, this is using the infinite formula here. So I need a1, which is 8, divided by 1 minus r, or 1/2. All right, so this is 8 divided by 1 minus 1/2 is 1/2. 1/2 goes into 8 16 times, and that's the answer. In this next example, I'm also doing another infinite sum, and if we start looking at the things that I need for the calculation, a1 and r, I can see that r is going to be equal to 3/2, which happens to be more than 1, and in this case I'm not going to try to do it because it's impossible. So remember, you can only do infinite sums if the common ratio is less than 1, if it's within 1 unit away from 0. So this is impossible. This is an example more like example A up here, where the numbers just keep getting bigger and bigger and bigger, and you're not going to be able to add them all up. Okay, and that is all.